So if you're using AI, you've probably noticed that AI often gives different responses to the same prompt. So for example, if we have a prompt like, what are the best flavors of ice cream? And we ask that multiple times in different chat windows, we'll often see that the responses differ. So here, what we're plotting are the visibility values for different flavors of ice cream. So the percentage of responses that they appear in. And we can see that there are some classic flavors like vanilla, strawberry, and chocolate that appear in every response. And then there are many other flavors that only appear occasionally, for example, black sesame and honey lavender. So why does this happen? There are several reasons why the responses might differ, but there's a really important one that a lot of people don't seem to know about. And I wanted to talk about that today in this video. So in order to do that, we need to know a little bit about how large language models generate text. So despite the amazing kind of emergent capabilities and intelligence that you can see in the responses from large language models, they're still really just generating responses to your prompts one word at a time. Actually, one token at a time, but for this video, we're going to think of tokens and words as being the same thing. So let's suppose we have a sentence like, the best project management tool is, and then we want to generate the next word. How is a large language model going to do this? Well, first, it's going to predict a probability distribution over all the possible words that could appear here. In this case, given this context, the next word is probably the name of a project management tool. So you can see here that those are the top options that get the highest probabilities. And essentially, the probability is higher if the word kind of fits better in this context or in this sentence. So now, how do we actually pick the word given these probabilities? You might imagine that we pick the most likely word, but actually what happens is we pick the word randomly according to these probabilities. So you can think about this as we have a giant weighted die, and there's a face on the die for each possible word that we could generate, and the weight of each face is set according to these probabilities, right? So essentially you have a 36% chance of rolling Jira. And so now what's going to happen is you're going to roll that die, and you're going to pick a word. And then you're going to repeat this process for the next word. And so then what can happen is if you have a different chat window, you get a different die roll and the response can differ. And this happens repeatedly, and this randomness can sort of compound over the course of the response. And the end result is that responses are generally at least a little bit different every single time you ask the same question. So the implication of this is that if you're doing something like prompt tracking, you have to be very careful and you cannot rely on individual responses. You always need to take a sample of responses, so get several responses to the same prompt, and then compute your metrics over that sample. So an interesting thing about the randomness that I mentioned is that this randomness actually compounds over the course of the generation. So what do I mean by this? Die rolls for selecting the word that happen earlier in the generation of the response. It's being generated left to right. So words that are generated earlier, those words then affect the probabilities of later words in the generation. And so sort of an extreme example of this would be if you do something like you ask a subjective question and then you try to force the model to choose either yes or no and then justify their response, right? So in this case, we have the question, is it wrong to steal food to feed your starving family, right? So this is a sort of subjective moral question. And what we can see here is we're actually generating this kind of tree that shows all the different options that could be generated, right? And so the very first thing it has to decide is whether it should choose yes or no. And what's interesting is that, so it looks like here, it's more likely, the circle being bigger means it's more likely to choose no, but it could choose yes. And depending on that initial choice, the entire rest of the generation is going to be completely dependent on that. So if it says no, it's going to try really hard to justify that. And if it says yes, it's going to try really hard to justify that. But what's interesting is that initial selection of yes or no is, pretty close to 50-50. And so basically this one initial choice can completely change the shape or the course of the rest of the generation.